Welcome to the world of object-oriented analysis and design. This is Dr. Gunamani Jana. In this video, we'll be covering the concept of object-oriented. Let us first start with the object. Most of the students they confuse about the class and object, whether an object is created first or a class is created first, whether object is an instance of a class or class is a collection of object. So all these concepts, and then we'll start our Java program, right? As you know, that object is just like a software bundle, and here it represents the state and behavior. Two things are important. One is the state, and another is the behavior, how it performs, how it functions. And these software objects they are often used to model the real world objects. What of the software object we are taking and discussing now? Mainly they are used to model the real world objects. The real world, whatever things we want to implement or you want to do, that is modeled by the software models, software objects. So these two things what I told you that we need the state of the object and also the behavior. So they both are represented by the objects. Say for example, state is represented by the fields. This behavior is represented by the methods, right? And this object, this introduces the concept of data encapsulation and also explains the benefit of designing our software in this manner, right? Now, while we come for these classes, this is just like a prototype or whatever we said is a blueprint from which object is created. So class is a prototype. From this prototype, our object is created. Remember this one. Then this class, what is the job here? It models the state and behavior of the real world object. What is the real world object we see? Those are modeled by these classes with the objects, right? So it intentionally focuses on the basics, showing how even simple classes can be clearly modeled. Now, coming to the concept of object-oriented analysis, if you see, the first thing is the inheritance. In this inheritance, it provides a powerful and natural mechanism for organizing and structuring our software. For organizing and structuring our software, we need this inheritance. Okay. So, what exactly it inherits? See, classes inherits the state and behavior from the superclasses. So this saves a lot of coding and also time because if a class is already defined and if I have to inherit something, simply I have to copy and paste the same thing. But by default, it will be inherited. Okay. So this is the concept of inheritance. We can write a simple syntax. With that also, we can inherit all the state and behavior of the superclass to the classes. Then coming to the interface, the interface in general, we can understand it is a contract between class and the outside world. It is just like a contract. And what it promises, what is the purpose of this contract? It promises to provide the behavior published by this interface to the outside world. Right? So then we come and discuss about the packages. These packages, what we discuss in Java, it is just like a namespace for organizing classes and interfaces in a logical manner. And what is the purpose of this package? It makes large software projects easier to manage. Is it clear? That's why they are useful. And we introduces the application programming interfaces API provided by the Java platform. All things we'll discuss. Now, in broad, let us discuss about this object. So, as I discussed, the real world objects share two characteristics. One is the state and other is the behavior. Let us take an example of a bicycle. And all people, most of the people, they use bicycles. So, this bicycle have state. What are the state? You think about for a bicycle, what can be the state? The current gear. I'm talking about the gear cycle, gear bicycle, and the current pedal cadence and the current speed. These can be the different states. And what is the behavior? So we can change the gear. We can by changing, and we can also change the pedal cadence, and we can also apply brakes. So these are the behavior of that bicycle. Now, when you talk about modeling any object-oriented things or real-world things, then First of the things we have to identify what are the state and what are the behaviors. We have to note it down and accordingly work, right? So for each object, we can see we ask ourselves two questions. What possible states can this object have and what possible behavior can this object perform? So we note it down all the things. Then we start writing the object oriented programming, just modeling these real world objects, right? So this is the concept in our object oriented. Then while we are coming to the encapsulation, what exactly encapsulation? See, hiding the internal state and requiring all interaction to be performed through an object's method. That means subject is not directly interacting through the method, it is interacting. So this is called the data encapsulations. What is there inside, it is not starting outside, but through the method it is interacting with the outside world. Okay. So this is a very fundamental principle of object oriented programming. Now, from this diagram, we can clearly understand how we represent a software object. See, software object, we told that two things will be there. One is the state and another is the behavior. The core part, whatever you see, the different, circle are there, pentagon, hexagon, all the things are there. So this is just a pictorial things. So these are the fields or the various state. This is the state. And we need some methods or the behavior. You can see a circle here, circular space here surrounding this state. And if you compare the bicycle, what we just have taken an example, in the state we can have, say for example, it is a geared cycle, so the fifth gear is there. What is the RPM? Say 90 RPM is there. What is the mile per hour? It is 18 mile per hour. So these are the state represented by the fields. And coming to the behavior, so change the gear, apply a brake, change cadence, all the things are there, the behavior of the things. Then what benefit we get by bundling code into the individual software objects? See, first one is the modularity. What exactly this modularity? The source code for an object can be written and maintained independently of the source code of other objects. So once created, an object can be easily passed around inside the system. That is the modularity one upon another. Then coming to the information hiding, by interacting with the object's method and hiding the internal details, lower details. This is called the information hiding. Okay. So what is there inside that is hidden to the outside world. So interaction is only possible through the object's method. Then the reusability, which is the major concept in the object oriented, it is if an object is already exist, perhaps written by some another software developer, we can use that object in our program. This allows specialists to implement, test, debug, and also complex task specific objects, which we can then trust because some expert have written we can trust to run on our own. Then pluggability and the debugging becomes easy. If a particular object turns out to be problematic, so we can simply remove it from our applications and plug in a different object as it is replacement. So that is possible. Now, let us implement that bicycle what I have seen, how we put it as a class and how we go for the different objects. How great. See, I define a class bicycle, and here, what is my state I am putting? The state are represented by the fields I put. The data type is integer. Int cadence is equal to 0, initialize to 0. Integer speed is equal to 0 and gear is equal to 1 because there is no 0 gear. You start with the first gear, right? So these are the states, what I told you that. Then we need some methods. You can say void change cadence. So integer new value. So cadence is equal to new value. Similarly, void change gear. These are all the methods. One, two, three. These methods, all the methods. I have given it there. Okay. So now, uh, so when while I am going to apply brake integer decrement, the speed is equal to speed minus decrement. Whatever things are there. Okay. So and I want to print the states. Void print state. This is the method. System.out.println. Some first you put what is the cadence. Cadence is equal to cadence plus speed. Then speed is plus gear is equal to whatever things you write it there, right? Now, like this, with some syntax, we can represent all the state as well as the behavior of this bicycle. What all things are there, right? Now, if you see here, how I created object from these things. Suppose I declare the class bicycle demo, then public static void main string arguments. So suppose I want to create some two different objects. So my object is bike one and bike two. So from this class bicycle, bike one is the object. So this is the method new bicycle method. Bike bicycle bike two. Yeah. Bicycle bike two is equal to new bicycle. So two objects are created. One is the bike one, second one is the bike two. Okay. How do we invoke the methods on those objects? Suppose I want to call the change the cadence. So for which bike? Bike one dot change cadence. This method I call for the bike one. So bike one speed up and bike one change gear and bike one print states. So for this object bike one, I did the things. Same thing for bike two also. I have done some different things. And while I go for the print the states or the what are the statements bike one. So it will show for the bike one cadence is equal to 50, speed is equal to 10, and gear is equal to 2. For the second, you see the bike 2, the cadence is 40, and the speed is equal to 20, and gear is equal to 3. Okay. So initially it was 10, so I added another speed up is 10, so it is 10 plus 10, 20. Is it clear? Now, while we are going for this concept of inheritance, see, what is this inheritance? Inheritance means carrying some property by default. Say, for example, a child gets the property of this parent. It inherits. By default, it has the right. The child will be getting all the property of the parents, right? So, like that, different kind of objects often have a certain amount of common with each other. There are common things. For example, let us say a mountain bike, a road bike, and also tandem bike. All they have the common property like a bike or like a bicycle, right? So it must have the current speed, it must have the current pedal cadence, it must have the current gear. All the things are there. Yet uh, each also defines some additional features. So we can inherit the default things. And what is the extra things we added there? That is the same thing it is done here. For example, object-oriented programming allows classes to inherit commonly used state and behavior from the other classes. In this example, bicycle now becomes the superclass. So mountain bike, road bike, and the tandem bike, all the things, they are the classes. And the superclass becomes the bike, right? So in the Java program language, each class is allowed to have one direct superclass. So this is a class, you can see this is a class. So they are having one the superclass. And each superclass has the potential for an unlimited number of subclasses. So this superclass can have a number here, three subclasses are there, right? Now, these things can be easily implemented also with a little syntax. See, I write class mounted bike, it extends bicycle. So bicycle is the superclass. So this mount bike is extension of that one. That means what are the state and behavior of the bicycle by default it will come. Some additional things for this mountain bike or that. Okay. So these are the things we do it here. Then, while we go for this interface in our next class, I hope up to this fundamentally and professionally we are able to understand what is the concept of this object, class, inheritance, package, all things. Thank you for watching this video and have a good day. Thank you all.